Good morning, friends. Hope that all is well. I'm back for part two of module number 10, Ecology. This section is entitled Mutualism, and I'm on page 305. You ready to read along or listen along? Okay, here we go. Although the previous section concentrated on the predator prey relationship, there are other relationships that exist between organisms and an ecosystem. For example, we've already discussed the phenomenon of mutualism, a specific form of symbiosis in which two or more organisms live in a mutually beneficial relationship. In module number 3, for example, we discussed the termite and the protozoa from genus Trichonympha. Say that one with me. Trichonympha. The termite eats wood, but cannot digest one of the principal components of wood, cellulose. Since the termite cannot digest cellulose, it is not able to eat wood without some help. The help comes from the protozoa of the genus Trichonympha, which live in the gut of termites and eat the cellulose that the termites cannot digest. This keeps the termites alive while providing an ample food supply for the protozoa. In module number 4, we also learned about the mutualistic relationships between algae and fungi, which we call lichens, as well as the mutualistic relationships between plants and fungi, which we call mycorrhizae. It turns out that there are many examples of mutualism in God's creation. The three that you have already learned about are examples from the land, but there are also incredible mutualistic relationships that exist between organisms underwater. Consider, for example, the amazing life of the clownfish. See figure 10.4. These fish get their name from their bright orange and white markings. What makes them unique, however, is that they live among the stinging tentacles of sea anemones. Sea anemones are normally deadly to fish. Their tentacles are full of stingers, each of which delivers a paralyzing poison to any fish that touches it. Once the fish is paralyzed, the anemone eats it. This doesn't happen to clownfish, however. When a clownfish touches the tentacles of a sea anemone, it does not get stung. Although biologists do not know all of the details of why the clownfish does not get stung, they are relatively certain it has to do with the chemical makeup of a layer of mucus that covers the clownfish. This mucus is very similar to sea anemone mucus, and biologists speculate that the mucus fools the sea anemone into thinking that the clownfish is actually a part of the sea anemone. As a result, the sea anemone does not sting the clownfish. So the clownfish can swim in, out, and among the tentacles of the sea anemone without any adverse effects. As a result, the clownfish is protected from predators. After all, any predator that goes into the tentacles of the sea anemone will be killed. Thus, the clownfish benefits from the relationship by being protected from predators. The sea anemone benefits because the motion of the clownfish swimming near or in the anemone tantalizes predator fish. When the predator fish tries to attack the clownfish darts deep into the tentacles of the sea anemone. Often, the predator fish will be overcome with the desire to eat the clownfish and will not realize that it is being led into the tentacles of death. Thus, the sea anemone benefits because the clownfish tends to attract food to it. Recent studies also indicate that the activity of clownfish in a sea anemone frightens butterfly fish, which eat sea anemones. Thus, not only do the sea anemones protect the clownfish, but the clownfish also protect the sea anemones. Another example of mutualistic symbiosis can be found in the relationship between the blind shrimp and the goby, pictured in figure 10.5. These two organisms exist in most tropical seas, and they're usually found together. They both live in a hole on the ocean floor that has been dug by the blind shrimp. If you've ever been to the beach and tried to dig a hole in the sand under the water, you'll have some idea about how hard it is for the blind shrimp to maintain its home. Ocean currents are constantly throwing debris into the hole, so the shrimp has an almost never ending job of clearing the debris away from the hole. This puts the blind shrimp in danger because, as its name implies, it cannot see very well. It therefore has no way of knowing whether or not it's in danger of predators. This is where the goby comes in. The goby, a fish, has good vision. When the shrimp needs to clear the hole of debris, the goby goes out with it. While the shrimp digs, the goby keeps watch. The entire time that the shrimp is digging, it keeps one of its feelers on the goby. If the goby sees a predator, it signals the blind shrimp by flicking its tail, and they both head down the hole at lightning speed. Since the hole is too small for predators to follow, they are protected from danger. Once again, this is a mutually beneficial relationship. The blind shrimp benefits because it is warned about the presence of predators. The goby benefits because it has access to a hole in which it can hide from predators. Since the goby has no means by which to dig a hole, it would not have such protection if it were not for the blind shrimp. Even if it were able to find a hole that was unoccupied, the hole would fill up quickly from the debris carried by ocean currents. With the help of the blind shrimp, however, the goby gets a permanent home in which it can hide from predators. The last example of symbiosis that we want to cover is rather striking. It is the relationship that exists between two fish, the oriental sweetlips, the big fish in figure 10.6 on the next page, and the blue streak wrasse, the small fish in figure 10.6. It is an interesting relationship because the blue streak wrasse acts as a toothbrush for the oriental sweetlips. You see, the oriental sweetlips, like many fish, have teeth. If they didn't, there would be some underwater creatures without predators. As we've already seen, this would have disastrous effects on the ecosystem. Now, although teeth are useful, they actually are hard to maintain. If you do not clean them, they rot and fall out. Thus, the oriental sweetlips must have some means by which it cleans its teeth. How does a fish clean its teeth? A person cleans his teeth by brushing them. A dog doesn't brush its teeth to clean them. Instead, it chews on hard, edible substances like bones. This tends to flake the plaque and other cavity causing materials off its teeth. A fish could, in principle, do that, but there are very few hard edible substances available to many fish. Thus, the oriental sweet lips must find some other way of getting its teeth clean. The figure below shows you how this happens. After spending its day feeding on little fish, the oriental sweet lips decides that it is time to get its teeth cleaned. To do this, it looks for a particular spot on the coral reef, which is often called a cleaning station. When it finds the cleaning station, it swims up to it with its mouth wide open, and little blue streak wrasses dart out of the coral and swim right into the mouth or up the gills of the oriental sweet lips. These little fish then proceed to eat all of the plaque and other problem causing materials off the oriental sweet lips' teeth. This, of course, cleans the sweet lips' teeth, and it also provides an excellent meal for the blue streak wrasses. If all of this isn't amazing enough, the oriental sweet lips also knows not to chomp down on the blue streak wrasses when they finish their work. It allows the little fish to swim back out of its mouth so that it can have its teeth cleaned again tomorrow. Once again, this is a mutually beneficial relationship. Without the blue streak wrasses, the oriental sweet lips would lose its teeth. Without the oriental sweet lips, the blue streak wrasses would not have such fine meals. Studying these incredible relationships should give you an appreciation for the power and ingenuity of God. It should also tell you something about the hypothesis of macroevolution, which we studied in the previous module. Remember, macroevolution hopes to explain the origin of all species on this planet through competition and natural selection. Think about this hypothesis in light of the mutualism we have just studied. According to macroevolution, species should compete with one another for survival. The many examples of mutualism in creation tells us that species do not necessarily compete. They often help each other out. This flies in the face of a fundamental assumption in macroevolution. Mutualism presents a much greater challenge to the hypothesis of macroevolution, however. You see, macroevolution can never hope to explain many of the incredible examples of mutualism in creation. For example, think about how macroevolution would have to explain the relationship between the oriental sweet lips and the blue streak wrasse. At some point in time, macroevolutionists would say the sweet lips' ancestors probably had no teeth. In a number of generations, however, teeth began to form in a few of the ancestors' offspring. Now, in order for these teeth to avoid rotting and falling out, this new fish would have to develop the instinct for seeking out the wrasse, allowing the little fish to swim in its mouth and not eating the little fish when it was done with its work. This instinct, of course, would have to evolve at exactly the same time that the oriental sweet lips teeth evolved. That's not enough, however. At the exact same time that the teeth and instincts evolved in the oriental sweet lips, the blue streak wrasse would have to independently develop the instinct to swim right into the oriental sweet lips mouth without fear of being eaten. Remember, if all of these things didn't happen in the exact same generation, the system would not work. Obviously, It is ridiculous to believe in all of these chance coincidences occurring at the same time. Over and over again, however, this is what the scientist who believes in macroevolution must believe. When a scientist begins to look at the world around him, he sees far too many of these happy coincidences. Among all of the precisely balanced properties of atoms and subatomic particles, the incredibly complex web of interactions that makes life on Earth possible, the complicated nature of life itself, and the amazing design features of the animals we see in the world around us, it becomes obvious that this fantastic world around us could never have appeared by chance. It must have been designed by a powerful and intelligent designer. As Sir Frederick Hoyle, England's most, excuse me, England's foremost astrophysicist, who died in 2001, says, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Mutualism is just one more example of creation providing witness for its creator. All right, friends, what a great read, right? Okay, that was section 2. Join me next time for section 3 that begins the physical environment. Ta ta for now.